Hope you guys are doing well. Um, so continuing on our journey with data structures, today will be today we will try to understand array data structure, right? So basically, this is also called as a linear data structure. We'll try to understand what is meant by an array, how to uh, how to store elements in an array, how to read from an array. So basically, arrays can be broadly classified into two types, right? One is a 1D array, and then you have another is called as a 2D or a two-dimensional array, right? Now the question arises is why should we store data in an array, right? Or why should we use uh what's the advantage of storing data in an array? Now an array is basically a data structure that stores a um, fixed size sequences or same time contiguously. Like now this fixed size may vary, right? It may or may not be of a fixed size, or it may or may be of a same time, right? Now this it stores it contiguously, right? Now whenever we are talking about storing here we are not talking about how it is in the hard memory, right? We are talking about uh, with respect to uh, in the virtual memory, right? How is it stored? Now contiguous memory allocations, right? Now what do you mean by contiguous? Now this is with respect to the virtual memory, right? Whenever we are saying about contiguous memory allocations, remember we are talking about the virtual memory. In reality, they are just stored. So if you have a hard drive, right? On a hard drive, it will be stored anywhere wherever there is space available, right? So it is not when we talk about contiguous locations, we are not talking about uh, hardware where it is stored in the hardware. Instead, we are talking about the virtual memory. Now, in the virtual memory, they are stored in contiguous locations. Now, what do I mean to say by contiguous? So, if you have the starting address over here, if you have the base address plus the index will give you or would lead to the next elements in the array, right? So, this is basically what he means to say when array are in contiguous fashion is that means if you have the base index over here, so suppose this is the base index, right? The base index plus index 0, base index plus index 1, base address plus index 2, and index plus index 3 will give me the elements. Now generally these arrays are indexed. Now in C language like C, it is indexed from 0. You could also have be indexed from 1. You can also have negative indexing. In some other languages you have negative indexes as well. Now remember, they may or may not be of the fixed size, right? Because in certain languages like Python, you have the ability to grow the size, right? Because it is how internally it works, right? It stores it everything is Python is an object, right? So hence same type here again. This also may vary because there you are storing objects, right? Now the next thing that we are going to do is basically, so this is what do we mean by continuous, right? So if you have the base address, then base address plus the index is going to give me the first element. The address plus the index one is going to give me the first element of the array. So this is the second element, and base index plus the third third index is, so this is basically zero index 0 1 and 2. So this is actually index number 2, but I'm saying the third element of the array. So if you add the uh, base references plus to the, if you add the indexes to the base address, just you can get the next elements in the array. Now this arrangement is basically called as a row major, right? Because this is going to be followed in almost all languages. Now what is this row major? We'll see later on. Now row means that the rows. So while in the virtual memory, what is going to happen is we are going to move row wise, and then we are going to go to the next column. So for example, this is a 2D array. So first basically we are going to store this row, and then we are going to go and store this row. So first is, so we are moving the way we are deciding the behavior is we are moving row wise, and we are not going column wise. Now the advantage is, so first is the row one, right? So then if I do so this will be indexed like This is the row, and this is the column. So this is the first element of the column, first, second element, and third element of the row 1. Then again we'll be incrementing the row, and this is first, second, and third element of the row 2. So this is how a row major elements are stored in memory, right? Now, if it's a column, then instead of having 1, 2, 3, 4, 5, 6, it will be stored as 1, 4, 2, 5, and 3, 6. So the way the loop will also be have to be altered, right? Because we are going to change from row 1 to row from column 1, column 1 full, and this is row 1 and row 2. So it is going to vary how the inner and outer loops are going to be written. Now this is most important. That the advantage of using row or column measure is what we are trying to achieve is basically how are we going to store the elements in the in the virtual memory, right? Which would, when you use the loops, that you're going to access the virtual memory, right? Okay, so this is basically a little bit more it's the same thing. So basically first I'm doing is I'm passing on this row. So I have 0 element, 0 1, 0 3, and 0 2, right? So this is the row. So remember, the row is constant over here. The only parameter that is changing is the column. Again, when I go to the row 2, the row 2 is going to be the same. What is changing is basically the indexes, right? Now, accessing single elements. Now, whenever we are talking about accessing single elements, the time taken to access one single element is going to be often, right? We basically mention in the index over here. So, for example, this is array of 0. So, array of 0 is directly going to give us 1. Then you have array of 1. It is directly going to give us 2, right? So, if it's a say 1D array, to access one single element, the time complexity needed is going to be O of 1, and this is basically the constant time of the array, right? Now, if I want to access all the elements of array, so for example I need to print all, then I need to go to each elements one by one by one, right? So basically it is going to take the length of, so we are assuming that the length of the array is n, right? So it is going to be it is going to take n, right? Because we are going to visit all the elements one by one, so it is going to be O of n times. Now, how are we going to do access? So now, how is the complexity going to work in a 2D array, right? So remember, 2D array, what we are stored is, first we are going to store the row 1, and then we are going to access the individual columns, right? So basically, if I have a row of say length n, and then I have columns of say length n. So for one element, for first for one row I have to travel n elements, n columns. Similarly for the second row I have to travel n columns, right? So if I have n rows, then I'll be traveling it as n cross n, basically O of n square time complexity. This is basically what I'm trying to say. This is for row 1, right? Now if this is tending towards n, because we are always doing asymptotic analysis, right? We are assuming that the input is going to tend towards infinity, so then it is going to be n, and then this is going to be n into n, basically n square times. Now this is a drawback. So whenever we are accessing if I'm going to pass through all the elements of the for 2D array, then it is going to be O of n square. Now if it is going to be 3D array, then again we need to go one more dimension, right? So basically we are indirectly increasing the time complexity if we are visiting each and every element of the array in a 3D array. However, we won't be dealing with 3D arrays, but this is just like a general knowledge or a basic thing about how. Uh, so basically, if it's a this is a 2D array, right? So if it's a 2D array, then this is n cross n, right? For example, if I'm so what I'm trying to say is, suppose if this is for each row, right? This row is has to tend towards n, and then for each row I'm going to do n columns, right? So that is going to give me a n cross n time complexity, which is n square. So hence what I'm trying to say is, if you're visiting each and every element of a 2D array, it is going to take you n square times to visit the entire, this is going to visit the entire 2D array. To visit the entire 2D array, I'm going to take n cross n, basically n square times. Now so what if I have an array? Now there are special arrays, right? There's something called as spatial arrays. Now remember, in which only the diagonal elements are one. So this is a special type of an, it is also called as an identity matrix, right? Remember. So the special part of this type of array is only the diagonal elements of it. The diagonal elements of the array are going to be one. So if I want to perform some operation, then I just need to, because even if you are going, so this is all the diagonal elements are one right now. This is a very important property, right? What if I'm multiplying it with another array? Now the way matrix multiplication is works is row of first array multiplied by column of second, right? And then the elements are summed up. So if it is anything, so 0 times anything is always going to be 0. So the only thing that is going to contribute to my, so instead of visiting all the elements for contributing, I just need to visit the diagonal elements. Now the diagonal elements is going to have a property, right? So diagonal elements can be calculated as when I is equal to j. So this will be like it will be indexed as a 0 0, right? This will be indexed as a of 1 and 1. So basically what I am trying to say is here the number of rows and the number of columns are going to be the same. So I just need to visit those elements instead of traversing the entire array. This is a special type of array, right? This is called as identity matrix. So identity matrix will, so this is now why this is used, because whenever you are storing images, right? For example, you have an image matrix. The real world example is like a image matrix, right? So only you have two colors, right? One for white and one for black. So whenever you want to perform convolution is when you are trying to multiply two matrices. Whenever trying to multiply two identity matrix, we only just need to you just multiply the diagonal elements, remaining all elements. So instead of looping through all the elements, the diagonal so for the first matrix we only need, okay, like what I'm trying to say is, so suppose if I have two matrices, right? So 1 0 0 0 0 0 0, and I have another matrices over here which is 1 0 0 0 1 0 0 0. Now the only contributing factor in this, yeah, just let me have a better color so that it's more visible. 1 0. So the only thing that we need to multiply is these two, and again we need to only multiply these two, and we need to only multiply these two, because the remaining elements are all going to be 0, right? That is how an identity matrix works. So basically what we are doing is we are reducing the number of visits of each element. So whenever you are with array, right, the best way or the way to improve the complexity is try to reduce the number of visits. If you are the lesser number of times, the lesser number of elements that you are visiting in the array, the lesser is what the resultant answer is going to be, right? So that is a very popular case. Now sorted arrays. Now this is again one very peculiar case of an sorted array. Now arrays can be sorted in two ways. Then you can perform sorting in then you can do it ascending order sorting, or you can have a descending order sorting, right? So whenever we are basically going to deal with ascending order sorted. So whenever we have an ascending order sorted, so if this is the element, so what is going to, if you pick any element in the array, the elements to the left of it will always be small to it, and the elements to the right of it will always be bigger to it. So this is a very big cue in various problems, right? Whenever you are having a sorted array issue, always remember that any element you pick, the element to the left of it will always be 0. Like the only exception is when you are over here, right? Because there is nothing on the right hand side. So that is one exception case that is very much understood. The rest, if you take any element in the array, even for the last, there is nothing on the right hand side, right? So other than that, if you take any element, so if I take 2, towards left of it I have 1. Basically this is how like a number line, right? So if you have a number line, if you ever see a number, this is 0, right? So elements to the left of the number line is always less, and to the right is any. If you take any element on the number line, the elements to the left will always be smaller to it. The element to it to the right will always be greater to it, right? This is how elements are placed on a number line, right? So that is a very cool property, right? So for example, how what application? So there is a very famous thing, right? Now, for example, if I'm set to find a pair of numbers, that pair of numbers that is going to give me a sum of say x. Now, I am going to find a pair, right? Find all the possible pairs that are going to give the sum x. That is what I am trying to find out. So if I take each number, right? For example, if I want to find a sum of 10, and I'm going to iterate to number 1. So what I can do is, so if my 1 plus this number x is going to give me some 10, right? So can I write my x will be 9? So I know x is 9, right? Now this gives me two behavior, right? Remember x is what it says is, then this number will always be towards the right side, right? So I don't need to search the left side, ignore the left side. So that is what logic you can apply, right? For example, if I'm going to find two numbers, right? So for example, let's say I'm finding so let's say I'm going to find 4. I need to find two numbers that give me a sum 4, and I'm standing at number 2. Now I know if uh, so what I'm going to do is, so let's say 3. So then if I do my sum minus 3, right? So I'm going to get my number should be 1. Now from this number itself, if I compare it with 3, I know that this is a sorted array and this is smaller. If this is smaller, then I 100% know that this will be towards my left hand side. So I don't need to worry about the right side. I can just ignore it. Just go on to the left and forget about what is there on the right. So this is a very big advantage of sorted arrays. I remember, so there is one more caveat to this. Remember, strings are also stored as in the form of characters array, right? So if I have a string, the way it is stored is it is stored in the form of a character, right? So the way you can access is, again, you can access them character by character. So it's, if this is ABC, now in most language this is going to be an array. Array of characters is basically a string, right? So internally it is even these are indexed, right? So this can be index number 0, this is index number 1, this is number index number 2, and so on and so forth. So as we say, array of if there is an array, and if there is a sorted array, now this is we were discussing sorted array, right? If there is a sorted arrays, except for the first and the last values, if you pick any number, the number to the left of it will always be smaller than to it, and the number to the right will always be bigger. So whenever you are finding 2 sum or 3 sum or any other such operations, or you are finding a 4 sum, remember, uh, the whole point is that if it's a number that is, this is very applicable so this sum minus is very applicable in two sum, right? Even three sums it becomes a bit difficult because uh, just because we only need to guess one, right? So we can easily make that guess which side of array should I look. Now when I have 3, I have a plus b plus c, right? So I have two more possibilities that come into, so that is going to be so that logic is little bit complicated. There is another way as well to solve it. We'll see that later on. So this is basically what I was trying to say. So if my sum is 10, so then I say, and if suppose I'm assuming A is to be 3, then my B has to be 7. Just by looking at this 7, I can say, you know what, since this is a sorted as array, since 3 is smaller than 7, that means the 7 has to be present on the right hand side. So just search for 7 on the right hand side. If I'm able to find 7, then yes, I have the second, then I have the pair that is going to give me the resultant, right? If I don't have 7, then I cannot have that pair. Now what is a subarray? Now subarray is basically a contiguous part of an array, right? For example, this 1 is a subarray, 2 is a subarray, 3 is a subarray, 1 and 2, again these are going to make it. So whenever you're considering two things, right, it should be a contiguous, like they should not be. So this 1 and 3 cannot be called as a subarray because they are not continuous, right? So the only drawback of whenever we are searching for a subarray is the whole idea of subarray is basically to have array, part of an array which is basically contiguous in nature. If it's not a contiguous in nature, then we cannot call it as a subarray. So just revising, so if I want to access a single element, it was just going to take me O of 1. If I'm going to access, if I need to access all the elements of the array, it's going to be O of n when it's a one-dimensional array. Similarly, when I go for a 2D array, accessing one single element is going to be again O of 1. If I'm going to access the entire 2D array, then it's going to be O of n. Now there are special arrays in which only the diagonal elements are 1. So whenever you are performing matrix multiplication, there is no need to check or there need to pass through all the elements. Just we need to just multiply the diagonal elements, right? That is what is going to give me the resultant. The next part that we thought about is a sorted array, right? If it's a sorted array, if just by if we like ignore the first and the last element of the array, rest all elements will follow a certain property, right? What the properties is if there is any number, the set to it will be on the left hand side, and any number that is right hand to greater to it will be on the right hand side. Then what is the subarray? Subarray is basically a part of an array, right? Now the way we define subarray is, the important part of a subarray is that it should be contiguous in nature. If it's a contiguous in nature, only then we say that it is going to be a subarray. Only then it qualifies that it is a subarray, else it does not qualify as a subarray. So I guess yeah, that is all for this session. I hope you guys liked it. This was just a brief intro about arrays. I'll see you guys in the next one with little bit problems of an array, and then we'll try to see how to apply best case, worst case, like how to solve the problems, right? Array related problems. So we'll see that in another video. So in the next we'll start solving problems. So I guess that's all for this session. I hope you guys liked it. I'll see you guys in the next one. So language is not the barrier. We can do in any language you want. We'll do in multiple languages. So that is all for this session. I hope you guys liked it. I'll see you guys in the next ones, and please subscribe to my channel. Till that time, take care. Bye bye.